Hello, my name is Lola Golden, a sport and exercise student at Baswick. Today I'm going to introduce you to the key concepts of speed and velocity and how they apply to sport and examples. Distance and displacement are both measures of how far an object has moved, however they both have specific meanings. Distance refers to the total movement of an object no matter the direction. For example, if an athlete runs around a track, the distance they travel is simply the total length of the path they have taken, regardless of the start or finishing point. Distance is measured in meters. Distance can never be negative because it's a total measure, so it's always a positive value. Distance is scalar because it only looks at the amount of movement and not the direction. An example is a 100-meter sprinter. The runner could run 100 meters in a circle or 100 meters in a straight line, but their distance remains 100 meters no matter the path. Another example is a rounder's ball being hit by the batter. The distance of the ball is measured by how far the ball has gone from the starting point. For example, the batter at the start would be 0 meters, and if she had a good strike on the ball, it could end up 15 meters from the start. Displacement is the shortest straight line distance between the starting and finishing points, and it takes direction into account. For example, if an athlete runs 100 meters straight north, their displacement would be 100 meters north. However, if they ran around a circular track for a 400-meter run and ended up where they started, the displacement would be 0 meters, even though the distance is 400 meters. Displacement is also measured in meters like distance. Displacement is a vector because it includes both magnitude, which is how far an object has moved, and direction. This means it tells you not just how far you've travelled, but also which direction you've gone in. If a swimmer swims 100 meters in a 50-meter pool, the distance they cover is 100 meters. However, that sprinter has started and finished at the same point. Therefore, their displacement would be 0 meters because their displacement is based on the change in position and there was none, as they ended up where they started. Another example is a javelin. When a javelin is thrown, it travels through the air and covers a certain distance from its starting point to where it lands. The displacement is the straight line distance from the initial position to the final position, along with the direction of that line. Distant time graphs are a visual representation of a system's distance covered in comparison to the time it has taken them to get there. The gradients of the line mean specific movements such as acceleration, deceleration, stationary, or constant speed. They can allow us to analyse an athlete's performance in further detail. For example, when looking at a 200-meter runner's race on a graph, we are able to see when they accelerated the fastest, when they slowed down, and when they were maintaining a good speed. The axes on the graph represent different things. The x-axis, which runs along the bottom of the graph, represents time, which is in seconds. It shows how much time has passed. The y-axis, which runs up the graph, represents distance in meters. It shows how far the object has moved. If the graph is a horizontal line, it means that the object is stationary, as no distance is being covered over time. A steep upward slope indicates higher speed because the object is covering more distance in less time. A shallow slope indicates slower speed, meaning the object is moving a shorter distance over a longer period. Curved lines show changes in acceleration or deceleration. Curved lines show changes in acceleration or deceleration. For example, Curved lines show changes in acceleration or deceleration. For example, if a sprinter begins running slowly and then speeds up, the graph will show a curve starting lower and then rising more steeply. And if a sprinter was sprinting and then they slowed down after the finish line, the curve would start off steep and then plateau. Speed is simply the measure of how much distance an object travels in each amount of time, but it does not consider direction. For example, if a sprinter runs 100 meters in 20 seconds, it's moving at a speed of 5 meters per second, regardless of whether it's going straight or turning. It is measured in meters per second. The speed is a scalar because it only considers the amount of distance covered, not the direction. It tells you how fast an object is moving, but not where it's going. If a sprinter completes a 100-meter race in 10 seconds, their speed would be speed equals 100 meters divided by 10 seconds, which equals 10 meters per second. If a bowling ball is thrown down an 18-meter alley and it takes 3 seconds, then the speed of the ball would be 6 meters per second, as we're dividing 18 meters divided by 3 seconds, and then you get the speed. Velocity is like speed, but it also includes direction, so it tells you how fast and in which direction an object is moving. For example, if a frisbee is travelling 10 meters to the north in 5 seconds, it's moving at a velocity of 2 meters per second to the north. Velocity is measured in meters per second, just like speed, but velocity also includes specifying the direction. Velocity is a vector because it considers both the magnitude, how fast, and the direction. So you can say an athlete is running at 8 meters per second to the east. If a cyclist travels 100 meters to the north in 20 seconds, the velocity would be velocity equals displacement divided by time, which equals 100 meters divided by 20 seconds, which gives a velocity of 5 meters per second to the north. If a football player kicks a ball 20 meters to the east in 2 seconds, the velocity is velocity equals 20 meters divided by 2 seconds, which equals 10 meters per second to the east. Velocity time graphs are like distance time graphs, but instead of the y-axis representing distance, it represents velocity. The x-axis remains representing time in seconds. A horizontal line at a certain value shows constant velocity. The object is moving at a steady pace in a certain direction. A steep upward slope indicates acceleration, meaning the object is speeding up. A downward slope indicates deceleration, meaning the object is slowing down. If the line crosses the x-axis, becoming negative, it indicates a change in direction. For example, an object reversing direction. These graphs can allow us to analyze an athlete's performance in further detail. For example, when looking at a 200-meter runner's race on a graph, we can see when they accelerated the fastest, when they slowed down, and when they were maintaining their speed. This is known as looking at their splits. In this example, Usain Bolt and Amber Anning are both elite athletes who have performed in the Olympics. By having a velocity time graph of each of their 200-meter performances, I can compare my 200-meter performance to theirs. In this example, we have broken the splits up into 50 meters. After comparing, this can help me see where I can improve in my run. In this graph, we can start with the first 50-meter split. As you can see, all three lines show that there is a steep acceleration in our runs between 0 to 50 meters. Then as we look at the 50 to 100 meter split, you can clearly see that Anning and Bolt continue to accelerate but at a lower intensity, whereas my line has plateaued, which means that my speed has not increased. By using this graph, I can see that this is where I can improve my run to get a better time, as that is a technique elite performers use. Between the 100 to 150 split, Bolt's data shows that there is a slight decrease in his speed, whereas Anning had a steeper deceleration, and my data shows that I had a slight acceleration in my speed. By comparing my data with elite athletes, I can see that my 200-meter technique isn't as efficient as theirs, which could be impacting my time. For the last 50-meter split, Bolt continues to slowly decelerate, whereas Anning finishes her run off strong with a steep acceleration, and my data shows that I had a steep deceleration in my speed. By using this graph, I can see elite performers' running technique. For example, Bolt accelerates in the first 100 meters, then finishes the run off at a lower speed, whereas Anning accelerates, then decelerates, then accelerates again. This graph highlights the key differences between my performance and their performances, which can then be used to create training that will improve my technique. This is how performers can improve their performance by comparing their data with elite athletes of a higher level to create a training plan as to how they can improve. Thank you for listening.